There's been a lot of work over decades on the Olduvai paleolake. There's no lake at Olduvai Gorge at present, but there was one long before. And today I'm really going to concentrate on some of the recent work done by the Olduvai Gorge coring project. So where are we? We've gone down to the southern end of the East African Rift here. So the previous talks were focusing on Ethiopia. We've bypassed Kenya and gone down to Tanzania, and we're in northern Tanzania here. And Olduvai Gorge is actually not in the rift proper. It's on the shoulder of the rift in a basin associated with the rift. And you can see it here on the Landsat image, the kind of two branches of the gorge coming together. So that is where Olduvai Gorge is. And one thing you will notice is that there is no lake there today, and is directly adjacent to the Ngorongoro volcanic highlands, which supplied lots and lots of local tephra into the basin, which we've heard a lot about tephra in the last two talks. Another thing I can show in this Landsat image is the three modern rift lakes. We have Lake Natron to the north and Eyasi and Manyara to the south there. So these rift lakes have been a prominent feature on the landscape in this area for millions of years. So Olduvai Gorge is a famous hominid site. An outcrop starts about 2.03 million years, and multiple hominid fossils, great record of stone artifacts showing kind of the transition from the Oldowan to the Acheulean, really famous sites for that, and extensive non-hominid faunal remains as well. And I just love this this postcard with the floating head of Zinjanthropus looking over the outlook, the overview that tourists can go to when they go to Olduvai Gorge today. So this diagram here is showing Olduvai stratigraphy, and since I got my start at Olduvai working on tephra stratigraphy, everything in color here is the sequence of tephra, mostly quite proximal tephra that we have throughout the Olduvai beds. So as you can see, we have about 100 meters of sediment represented there, and a variety of different volcanic ashes over time. But the thing I'm going to concentrate on today is not that. It is the leftmost column here, and that is the lake. So no lake today, but during bed 1 and bed 2, which are the most highly fossiliferous times in the Olduvai record, there was definitely a lake. It was a kind of a lake-dominated basin there. And we see evidence and outcrop of that lake shrinking and eventually disappearing over time, going towards the more modern landscape. And we see associated changes in the fauna as well. So here is one of the more famous lake sediment outcrops for Olduvai. This is RHC, named after Richard Hay Cliff. And everything in green there, and those lower bed 1 and part of bed 2 there, that is kind of green lake deposits there. And the green is from those green lake claystones. And those green lake claystones also contain chert. They also contain some carbonates, both calcite and dolomite. And my favorite, they contain zeolites. And I've been focusing in on the zeolites in a way as a continuation of Richard Hay's work, because zeolites are minerals that can tell us something about the lake conditions. They can tell us something in particular about aridity and and how saline alkaline this lake was versus how fresh it was. So problem we run into at Olduvai is that we have this beautiful long gorge that exposes these great outcrops, but lakes are not usually long linear features. And so when we want to reconstruct the lake, we have to extrapolate to kind of get its dimensions correct and to really kind of track it changes over time. And so one of the things you can do to do that is to core. And that was first done at Olduvai in 2014 by the Olduvai Gorge Coring Project. And you can think of this as being kind of the natural southern extension of the hominid sites and paleolakes drilling project that included Joe Barrier as well, and many sites within Kenya as well. This is Olduvai is a little bit to the south here. And so when we first went into do coring at Olduvai, we were using Hayes 1976 lake kind of lake depot center extrapolations based on outcrop. So you can see the Olduvai Gorge map underneath here, and using his reconstructions and our own mapping in these areas. We chose to do two cores kind of right where we could reconstruct the sections nearest to Olduvai there, but perhaps get fresher deposits that we could use for more paleoclimate indicators that were not affected by the weathering on the modern surfaces of the gorge. So we have two cores here, and then one a little bit further out. So this one's to the north, where we have way fewer exposures, a couple minor outcrops right along a fault there that let us know that we're getting into some kind of more lacustrine sediments up in that direction. And the blue on this diagram are showing kind of the extrapolated, anticipated lake depot centers based on Hay 1976. So he envisioned a lake that was changing in position over time, that in bed 1 and bed 2, contemporary with most of the major archaeological sites, it would have been in this area. And we see those deposits exposed in the modern gorge. But that this depot center would have moved northwards over time, kind of to the northeast here, through the younger beds. So bed 3, 4, Masek beds, eventually migrating further to the east to the Olduvai Depression, which is the current depot center, which is seasonally wet. So here's the drill rig coming in, right where all of the tourists can see. And so this is from the 2014 coring. I'm not going to give you much of a sneak peek of the 2023 coring, since that one's really just getting started on those cores. But from the 2014 cores, that we had 612 meters recovered in total between 4 cores, really excellent core recovery. And one thing that we did not anticipate was that in addition to that, 100 to 150 meters of core that we were expecting, based on where we see the Olduvai basin fills intersecting Precambrian basement and outcrop, we recovered 135 meters of new section below what was known from outcrop, which was unexpected but very welcome. So I'm not going to get into too much detail about the really detailed sedimentology that has been done on 3 of the cores here from 3 different sites. So we have core, remember core 1A and 2A, those were the ones that were closer to the gorge proper, and 3A is the core that was to the north. But what we have is in the upper part of the diagram there, between kind of the surface and that yellow line that I've drawn across there, that is where we have a correlative section core compared to outcrop. That's where we can really identify bed 1 and bed 2 and bed 3 and what we're used to seeing from outcrop. And so those are the ones that preserve the paleolake record that is most relevant to understanding the conditions under which the hominids at Olduvai were living. And everything below that level is new and not known in outcrop. And so the first part of that thick section is volcanics from up in Ngorongoro. But then we hit another paleolake interval below that, now referred to as the Nyberg-Soit Formation, before going back into volcanics again, and finally into another lake section here. And this particular core never reached bedrock, so we don't know, how much deeper we could have gone had we had the right equipment, because it was still kind of fluvio-lacustrine at the time when that core ended. But from seismics, we think we could have gone maybe even another 200 meters down before hitting basement.
Okay, Lindsay, that's 10 minutes.
Okay, great. So here is the newer reconstruction of the lake depot center for that bed 1, bed 2 time, based on the coring. And what we found is that we had a much more lacustrine record than anticipated. And core 3A was a big surprise because it showed the evidence for kind of the deepest water in some cases. And so we found that the lake was probably a much more permanent or prominent part of the landscape for much longer than anticipated there, and that it is deeply constrained by the faults, that the depot center is really likely is a kind of fault bounded to some degree, though at times of expansive wetter intervals with more expansive, then it would have taken over a much larger part of the basin. And one of my major jobs after doing the tephrostratigraphy for these cores was to do the X-ray diffraction, looking at how the minerals of the lake changed over time, to try to figure out what the authigenic minerals, so the minerals that formed in these lake sediments, were telling us. And so by comparing mineral by mineral changes within these cores, this was going on 1,000 samples. My students were very busy for a few years there. We were able to find different intervals where the mineralogy changed abruptly in the cores, telling us where we had some transitions within the lake, which could have been either geographic, change in where the lake depot center was, or climatic, if it was a freshening or drying out of the lake. And putting these together in some intervals of the core, we were able to see some potentially cyclical changes in mineralogy, with a focus on the zeolites here, where we could make out these wetter versus drier versus very dry intervals over time. And I don't have time to get into this now, but one cool thing is that these changes in zeolites were also tracking other changes within the cores. So changes in the isotopic biomarker, total organic carbon, other potential markers for a wetter and drier environment. So it was kind of cool to see the minerals really tracking that. And that was a very small part of the lake there. This is kind of the whole core. And we can see some just over the existence of the lake, that we can see some changes from highly saline alkaline to more intermediate. The zeolites were always there, but different zeolites can tell us, can constrain it a little bit different for indicating slightly fresher conditions. When you get the phillipsite and the analcime, it's pretty saline alkaline. But we also have this one nice interval that is a fairly fresh, recorded in the cores right there. So it was kind of nice to be able to piece together this long-term record.
Okay, Catherine, I think it's a hand clap, I guess.
Sorry, that was supposed to be a hand raise.
Okay, yeah, go ahead then. Go ahead with the
Lindsay,
question.
I'm wondering, you kind of demonstrated with your paleogeography there in the lake and the new data from the cores how important the faulting was for the basin
Yeah.
geometry. And I was wondering if you have any sense of timing of motion on those faults and kind of when they were active.
Mhm. Well, those I know that Harald Stolhofen has at Erlangen has done quite a bit of work on the kind of the faulting and this kind of sedimentary faulting there. So those faults were sedimentary. We do see evidence of them being active at the time of deposition of those sediments. And so the this lake, has always been in part present because of that the accommodation space made by those faults. And so it does kind of complicate using a lake like this as a pure climate indicator because the depth of the lake has to do with the availability of water for one thing, but also with the amount of accommodation space for new sediment to and in this case also this big fan coming off of the volcanic highlands, which at times of high activity can displace the lake as well. So we have this interplay between the faulting, the climate, and the volcanism here that affects whether we have a lake and what kind of lake it is.
Thank you.
So I have a question. So you've got this specific lake is cut by a gorge, so you can explore the geological history. I mean, how likely is it that there are other significant paleo lakes, I don't know, north or south along the rift that you know less about because they're not cut by erosion?
I'm sure absolutely positive that that's going to be the case. Though I mean there is quite a bit of erosion, in the East African Rift as well. But yeah, I would not be surprised at all if there's some unknown lakes.